Welcome back to Summarize Science. Have you ever wondered if planets outside our solar system have glorious rings like Saturn? Well, a new paper suggests that some planets might be caught in a cosmic recycling game, turning their moons into rings and back again, over and over. This fascinating idea is called the ring-moon cycle. It starts with a planet's rings slowly clumping together under gravity to form a small moon. Over millions of years, tidal forces from the planet pull that moon closer and closer. Eventually, the moon crosses a point of no return called the Roche limit, where the planet's gravity rips it to shreds, creating a brand new set of rings. Then, the whole process starts over. The researchers found that this cycle is very possible for large, non-spun planets similar to Neptune. Their calculations show these worlds could host rings for a significant portion of their lives, perhaps 20% of the time. And when they do, these rings could be even thicker and more substantial than Saturn's. But what about planets that are tidally locked, always showing the same face to their star? Normally, their rings would be invisible to us, perfectly edge-on. This study points out a clever exception. In systems with multiple planets, the gravitational nudges from neighboring worlds can cause a planet to wobble. This wobble tilts the planet's axis, making its rings visible when it passes in front of its star. This leads to the most exciting part, which could solve a major astronomical mystery: super puff planets. These are bizarre exoplanets that appear to have an incredibly low density, almost like cotton candy. The paper proposes that we might not be seeing a puffy planet at all. Instead, it could be a normal rocky or icy world surrounded by a huge, opaque ring system. This ring system makes the planet look much bigger than it really is, tricking us into calculating an absurdly low density. So to recap, this research establishes that ring-moon cycles are a plausible way for exoplanets to form and maintain long-lived rings. It identifies two key scenarios where we could detect them: on fast-spinning Neptune-like planets or on tidally locked planets that are being tilted by their neighbors. And most importantly, this process provides a compelling explanation for the strange superpuff planets we've observed. The search for exoplanet rings represents one of the next great frontiers in astronomy, and finding them would teach us volumes about how moons form across the galaxy. Detecting rings on one planet in a multi-planet system while others have none would be a smoking gun for this theory. What do you think about this cosmic recycling program? Let us know your thoughts in the comments below. And as always, thank you for watching Summarized Science.